So now we're going to jump ahead to number 26. The directions here are just find the area of the regions enclosed by the lines and curves. And then all it gives you is this equation, or this pair of equations, 4x squared plus y equals 4 and x fourth minus y equals 1. What are we going to do with that? All right. Well, the first thing that you got to do is you got to decide, am I going to do this as an integral with respect to y, like the last one I did, or x, like the first ones that I did? And the determining characteristic is you're going to say, which variable is it easiest to solve for? It's easiest to solve for y. So then I can just have y equals 4 minus 4x squared. And y equals, what's this should be, x fourth minus 1, since we're dividing by -1. All right, it's easiest to solve for y, therefore we're going to integrate with respect to x. All right, so it's easy to solve for y. But clearly you have to solve for one or the other here. All right, so now what are we going to do? Well, we still have to get a sense of what this thing looks like and find the intersection points. Sometimes it's helpful to know ahead of time how many intersection points are there. It can help you draw the graph. So maybe that would be helpful. We've got to do it anyway, so let's try that this time. We'll do that first. X fourth, so I'm setting the two equations equal, and I'm going to solve for x. So we know how to do that. We're going to have 0 equals x fourth plus 4x squared minus 5, and then this is a quadratic form, so I can factor it as x squared minus 1 times x squared plus 5. You can continue to factor this, but an easy thing to do is just set the factors equal to 0 right away. X squared minus 1 equals 0, x squared plus 5 equals 0. This one gives you x equals plus or minus 1. This one gives you no solution because you're going to have x squared equals -5. So plus or minus 1 are the only two intersection points. So we could probably pretty safely just do the integral of one thing minus the other from -1 to 1. But which function is on top? So that's the kind of thing that we have to think about how we're going to lay it out, and it's good to look at the graph. And by the way, you're perfectly welcome to graph these on your graphing calculator, or for this homework assignment, some of the things that are easier to solve for x, your TI calculator can graph those, but not very conveniently. So use Desmos. Desmos is great. You can just put in the equations just like that without solving for anything, and it'll just graph it. All right, but let's use our graphing skills. I know what y equals 4 minus 4x squared looks like. That's a parabola facing down. The x-intercepts are 1 and -1. Hey, that happens to be our intersection points. That won't always be the case, but it happens that the intersection points are the same as the x-intercepts. So that means these graphs share x-intercepts. So this is our y equals 4 minus 4x squared up here. And the other one is x fourth minus 1. This is easy to graph by transformations. I know that x fourth looks like x squared, except it's a little flatter on the bottom, and the -1 just drops it down 1, so we're down here at 1. And we can also easily find the x-intercepts to this are 1 and -1, or we know the intersection points are 1 and -1, so it has to have the same x-intercepts as the other graph did. So they intersect at 1 and -1. This is all important information that we need. So getting a handle on the graph is a really good starting point for all of these. All right, so now this is the area that we are trying to find. So now we can set up the integral, but we're going to learn a nifty shortcut that we could have used on one of the other prior problems. It's when you can't always use this, but when you observe that the graph is symmetrical, take advantage of the symmetry. This graph is symmetrical with respect to the y-axis. So instead of doing the integral from -1 to 1, I'm going to do the integral from 0 to 1 of my functions and then double that. All right? Does that save me work? Yes, because instead of plugging in -1 at the end, I get to plug in 0, and that's easier. So taking advantage of symmetry is a very useful technique when you're doing these areas. All right, so now everything else goes the same. I've identified now that the 4 minus 4x squared is the top function, so that goes first, and then the x fourth minus 1 is the bottom function, so that goes next. Combine my like terms, but don't lose this 2 as you go along. Just keep it on there. All right, so then I'm going to have, when I distribute out the negatives and combine like terms, negative x fourth minus 4x squared plus 5 dx. do your antiderivative, negative x fifth over 5 minus 4x cubed over 3 plus 5x. It looks terrible, but because you've taken advantage of the symmetry, you just have 0 and 1. All you're plugging in is 0 and 1. So when I plug in the 1, it's just negative 1/5 minus 4/3 plus 5. That's plugging in the upper limit, and the lower limit just gives me 0 because these are all 0. Right? So that's the advantage of using symmetry. All right, so then this is going to give you 2 times, well, let's see. I guess you can combine these two as 9/15 and 20/15. So negative 20, wait, is it 3? 3/15 and 20/15. So you got negative 23/15 plus 5. So the 5 is 75/15. So we're going to have 2 times 52/15. That's 104/15, and we'll just leave it like that. Boom. All right, the next one we're going to look at is going to be number 24. So if you want to have a look at page 396, number 24, remember the first question is, are you going to integrate with respect to x or with respect to y? Choose wisely.